All right, today we are pulling back the curtain on the engine that powers the entire Bitcoin world, mining. It's this incredible process that secures the whole network and creates new currency, all without a single person in charge. So let's dive right in.
And that brings us to this big fundamental puzzle. I mean, if there's no company, no CEO, no central bank, who's actually keeping the lights on? Who makes sure that when you send a transaction, it actually goes through and that nobody is cheating?
In the world we're all used to, we have a bank. They're the trusted middleman, right? They're the ones who say, yep, this transaction is good, and they can even reverse it if something goes wrong. But Bitcoin just throws that idea out the window. Instead, it relies on this huge global network of competitors that we call miners. They do the same job, but in a completely different, decentralized way.
And that whole process, well, that's what we call mining. At its core, it's how all the pending transactions get confirmed, bundled up, and then permanently sealed onto the public ledger, which you know as the blockchain. And here's the really cool part. It is the only way new Bitcoins are ever brought into existence. Okay, the absolute easiest way to wrap your head around this whole thing is to just think of it as one giant, nonstop, global lottery that's running 24/7. So how does this lottery work exactly? Well, first, all the miners out there scoop up recent transactions and pack them into a potential block. Next, the race begins. They all compete to solve an incredibly difficult cryptographic puzzle. This is like trying to guess the winning lottery number. Then, the first one to find the answer shouts it out to the rest of the network. And finally, if everyone else agrees the solution is correct, that new block is officially added to the chain, and the winner gets to collect their prize. Okay, the lottery analogy is great for a high-level view, but now let's pop the hood and look at what these computers are actually doing. Let's dive into the hashing engine. So this puzzle has a technical name. It's called proof of work. The entire system is designed to make it incredibly difficult and energy-intensive to add a new block. That's the whole point. Solving that puzzle is the literal proof that a miner has done the computational work and spent the energy to earn the right to update the ledger and get paid. Now, let's break down what's happening here. Miners take the transaction data and they add a random number to it called a nonce. That nonce is the one piece they can change. They then run this combined data through a hashing function, which spits out a unique digital fingerprint. The job of the miner is to change that nonce over and over and over again. We're talking trillions of guesses per second, until they finally produce a hash that meets a very specific requirement. And what is that requirement? Well, the goal is to be the first one to find a hash that's below a specific target number. A simple way to think about it is that they're looking for a hash that starts with a long string of zeros. Now, the really clever part is that the Bitcoin network automatically adjusts how difficult this puzzle is. Why? To make sure that no matter how many computers are playing this lottery, a winner is found, on average, once every 10 minutes. It's like clockwork. Now, as you can probably guess, this intense competition didn't stay a hobby for long. It rapidly evolved into a massive global industry, a full-blown, energy-fueled arms race. It's really wild to look at the evolution. In the very beginning, 2009, you could mine Bitcoin on a regular laptop CPU. Then by 2011, people realized that the graphics cards in gaming computers, GPUs, were way more powerful for this task. But the real game changer, the thing that created the industry we see today, came in 2013, ASICs. These are chips designed to do one single thing, mine Bitcoin. They were so unbelievably efficient that they made everything else completely obsolete, almost overnight. And to give you a sense of the power these things consume, a single modern ASIC miner can pull about 7,000 watts of electricity, nonstop. That's more power than your refrigerator, your dishwasher, and your washing machine all running at the exact same time, 24/7. So when electricity is by far your biggest expense, what do? You start a global hunt for the cheapest power on the planet. This is why we see huge mining operations cluster in places with low-cost energy, like Texas, or in really cold climates where they can save a ton of money on cooling the thousands of machines that are running red hot all day long. So with these huge costs for specialized hardware and mountains of electricity, you have to ask, why on earth do people do it? Well, let's break down the economics. When a miner wins that global lottery and adds a block to the chain, their paycheck comes in two parts. The big one is the block reward. This is a fixed amount of brand new Bitcoin that was just created. And on top of that, they also get to collect all the transaction fees that people paid to be included in that block. Now, that block reward is absolutely critical. It's the engine of new supply. It is the only mechanism that issues new Bitcoins into circulation, and it does so on a perfectly predictable schedule that's baked right into the code. And this chart shows that schedule perfectly. That yellow line is the block reward. See how it takes those sharp steps down? Those are called halvings. About every 4 years, the reward gets cut in half. And as that happens, you can see the white line, the total supply, start to flatten out as it approaches its final cap. It's a programmed monetary policy that creates predictable, ever-increasing scarcity. So what this all boils down to for a miner is profitability. This simple table lays it out. If your machine can earn you, say, $5 in revenue a day, but your power costs you $4.32, well, your profit is just 68 cents. It is a business of razor-thin margins, where every fraction of a cent really counts. Okay, so we've got this massive, competitive, global industry all fighting over tiny profit margins. What's the point of it all? This brings us to the key takeaway. All of this hardware, all of this competition, all of this energy, it's all about providing security. And I think this quote just nails it. The immense energy consumption isn't a flaw in the system, it is the system. It's the very feature that makes the Bitcoin network so secure. Think about it this way. For an attacker to go back and try to change the history on the blockchain, they would need to have more computational power than all of the honest miners combined. The sheer scale and cost of doing that is so astronomically high that it becomes practically impossible. It creates this incredibly robust digital fortress, securing billions of dollars in value. But this leaves us with a fascinating and really important question for the future. The block reward is the primary incentive for miners today, but it's designed to disappear. Around the year 2140, the last new Bitcoin will be mined. So what happens then? When that reward is finally gone, will transaction fees alone be a big enough prize to convince miners to keep running this massive wall of security? Well, that's a question the network itself will have to solve.